All right, welcome everybody to the regular, as in every other week regular, Delta RS Open Development Meeting. Today for the tentative agenda, we had a whole bunch of topics that we had suggested. So I tried to cut down a little bit, and if we get through these, then we'll go through everything else that we had in the Slack thread. But at a high level, I would Neville to share the 2.6 Parquet writer updates. I wanted Misha to then talk more about the dynamodb lock work that he's been doing. QP, I wanted to review some of the rustdoc progress to see what we need to still do there. I also wanted to make sure that we discussed granting Chris committer access. And then hopefully we'll have time to talk about surfacing writer stats through through the Parquet crate or up through Delta RS, which is a topic that Christian will leave. But let's go ahead and get started with you, Neville.
Awesome. On my side with updates, so I've materially completed the Parquet 2.6.0 write support. There's only one item pending in terms of data types that need to be written, and that's the decimal 128 data type. It's actually dependent on an open PR in the arrow side where we're still going through it, so it's still in a draft state. But with that said, it's just really the actual type, but the underlying fixed length binary type we can already write. So it's just semantics waiting for it to sort of be ticked off, and then we can sort of say we completely done with that. So I've just attached the umbrella Jira on the chat now. I'll also put it on Slack. But it just talks about the final work that I've been doing on the write support, supporting nanosecond timestamps. I think that was the big one for a couple of people. And then what I've also done in the past week is when trying to write tests or benchmark or even check what's working, what's not working, it's been very difficult because you sort of have to write the schema by hand and then generate the data by hand. So I opened a PR which I merged today to allow us to generate arbitrary random data. So you just provide the schema that you want. Very useful if you've got like deeply nested structures, with a struct list, etc. And then you supply the number of records you want, and then it generates that for you. So with that, I'm also just creating some benchmarks to look at a couple of to-dos that I'm left with in terms of cleaning up. The stuff that where I would write a vector of booleans instead of a bitmap, just so that I could be able to diagnose easily without having to worry about bit manipulation logic. So there's a bit of those things that I need to clean up. I'll run them up and just put them in a single gyro so that I can track them. But that's it from my side.
Do you have any questions for Neville? No.
I hope not.
Explain things perfectly. Well done.
Thank you.
That's fantastic that this support is coming in. I think I can speak to Scrib's specific use case in that I'm pretty sure we don't have any 128-bit decimals floating around. But it's great to know that work is coming in shortly.
Yep.
All right, the next topic that we had, Misha, if you could just go ahead and lead us and share the work that you've been doing on the dynamodb lock support, and I'll drop this link in the Slack channel as well.
Yep. So pull request still in draft mode, but I just need to figure out integration tests, and then the creation client within S3. But other than that, the Dynamo log workflow it's copied from Java Impl, meaning that it supports all of the major features such as acquiring log, updating, and releasing. And with a single addition from my side is that there's specific scenario where Java impl is lacking, and I address that in this implementation, is where the worker that holds a lock dies, and then there's more than one worker tries to acquire this lock. And in Java impl, when they try to acquire lock, there's least duration for which they wait, like by default it's 20 seconds, and only then it is able to expire lock. But the issue is that they are not, if the lock is changed, they're not extended that least duration. So only, for example, if you have like more than one workers, and both of them, like for example, if it's still both of them wait for 20 seconds, and only one, which is the faster one, will get a lock. Another will fail with a timeout. So that should not be our case. I extended that logic with the check that if the second worker which does not acquire a lock, it says that the actual lock has changed, like that record version number has changed. It will still it will then increase a timeout duration. That may cause to, for example, waiting for more than 20 seconds. But if the worker that's faster, which acquire lock, releases them, then we get a normal workflow. Anyway, that's a simple addition from me for our use case compared to.
Can I ask? Ask you? And I think QP, you've been collaborating on this a little bit. I wanted to ask. I see in this draft pull request that there's a new feature, like a new cargo feature for dynamodb that we'd be adding. I was hoping that maybe one of you could sort of share the reasoning behind adding another feature flag here.
Yeah, I can answer that. So we have not yet integrated dynamodb into S3 storage, but the idea is that not every use case will need a dynamodb lock. For example, if it's that single worker behavior, right, and they might not use the AWS S3, something like this. So they won't need a dynamodb lock within it. So they might just so we hide that under a feature, and only those that need a locking mechanism for multi-worker environment and have access to dynamodb, then only they might leverage of using dynamodb.
Gotcha.
Yeah. And also recently, one other note, I had a meeting with Chris on Kafka Delta ingest, and we were talking on how we can benefit from a Delta REST DynamoDB lock. Is that there's additional meta field data where we can store, for example, for Kafka Delta ingest, we might store a Kafka offsets, and for Delta REST, we might store a latest Delta version.
Sorry to interrupt, Misha. I may have lost the key piece of context. That's a metadata field in the DynamoDB row?
Yes.
Okay.
Yeah.
Please continue.
It's also in Java impl, but in lack of simplicity, I was not including that in Delta REST. But recently, we figured that it might be beneficial for us for Kafka Delta ingest to store the latest offsets, and for a Delta REST, we might use that for latest version. So instead of relying on optimistic concurrency, where worker tries to create a new Delta version in loop, right, with atomic rename, it just might start from the latest version instead of doing that in a loop. Yeah, and that's it.
Cool.
Also, just to add, in this DynamoDB lock, I've tried to copy every like Dynamo schema, another structure from and the final code to be similar to Java impl. So in case there will be an actual port of that library in Rust, we will be able to easily migrate to that. And yeah, that's it for me.
Any questions or comments for Misha?
Not a question, but a comment. I think a little later this week, we probably need to have an offline conversation with QP to catch up on some of the discussions we've had around exposing the distributed table lock in a lower level way to the Kafka Delta ingest API. That is all.
Okay. I trust y'all will be able to find each other to have that discussion. Except QP rustdocs. How are we doing?
Yep, this part is easy. So we have a work in progress PR open for adding Rust docs for all our Rust codebase. Florian has already added doc string for all the Python binding already. And the goal of that is to, once we have all the doc string added to public interfaces, we will enable missing docs linting rule so that all future code change require doc string in any new public interfaces, so that we could make sure that our documents are well documented. This is following the same rule that the arrow crates has set up, and we're just doing the same thing here. And anyone is welcome to send pull request to the docstring branch. We are currently, I think we still have 160 public interfaces still we need to add, but once we get that the CI to pass in that branch, we'll merge that into the main branch.
I plan on adding a PR for another big pass on this later. I'd like to get this in as soon as possible because we're going to keep growing the surface area of non-required rustdoc.
Right.
So the sooner the better. So I'll take another pass this evening.
What I'd recommend for anybody that's working on this, and this goes for anybody that's watching the video, is to also maybe announce what area you're working on for adding rustdoc in the Slack channel, to make sure that two folks don't have spend a lot of time adding the same rustdocs. QP, I'm assuming that, so this is pull request 156. I'm assuming once this goes green, we merge it, and then that's that, right?
Yep, that's the plan.
Okay. So pull requests for this should be targeting the rustdocs topic branch, and then pull request 156 will be automatically updated with that. Any other rustdoc related things we should discuss before we move on? No, we're moving through topics at a good clip. I believe the next thing that I wanted to have us discuss is QP suggested that Christian, who is the big letter C in this video call, Christian be granted commit privileges to the Delta RS repository. I think Florian, QP, myself, I don't know if Misha or Neville are committers at the moment. Let me go look.
Yeah, not.
Yeah.
Got equipment issues.
Not yet.
It's almost threatening. Soon, you will. So QP, you put this up, so I'm assuming you're in favor.
Yep.
Florian?
Yes. Yeah, right to access. Yeah.
All right, I'm also cool with this. So Christian, I'm clicking the buttons now.
Hooray!
And, great power, great responsibility, yada yada
Yep.
So Christian's been great at Red Access. Welcome aboard. Thank you for your contributions, etc., etc. I guess we should go into a next topic. That was actually, this is the last topic that I had sort of said that we definitely should get through. And maybe Neville and Christian, this is y'all, the stats support bubbling up through Delta RS, something or other.
Yep. Mostly just going to defer to Neville on this, but basically, the decision we're trying to reach here is for deriving the stats to include in each add action for a Delta transaction, where do we want that code to live? Do we want it to live in the Parquet crate, the Arrow crate, or in Kafka Delta ingest running compute kernels from Arrow? So Neville's done some research on this, so I'll hand it off to you.
Cool. Thank you. So broadly, there's two options. The first option is to compute the stats using the Arrow compute functionality. So we've got the minimum maximum kernel. I think we only calculate minimum maximum. The null count is already provided by the record batch. And then there's distinct columns. I think that's the only other one, but it's more optional than the others. The second option is to surface the parquet statistics for the file that has just been written, because we compute the stats as part of writing the file, and then use those statistics as part of the metadata to populate then the Delta statistics. So the main downside with the Arrow one is that from a physical data type perspective, we've got a 32-bit int, 64-bit int, float double, and then we've got byte array and fixed length byte array. So with the byte arrays, we don't actually have any methods in Arrow as yet to compute what the minimum, if you're looking at an IP address, for example, sorry, not an IP address, a MAC address for as an example, which you'd store as a fixed length binary byte array, we don't have any functionality to calculate what the minimum and what the maximum is, and Parquet actually requires those. So that's the one downside, in that there'd be a bit of extra work that we need to do just to write the minimum kernel for binary data, minimum and maximum for binary data. Now with the Parquet one, there's a slight challenge, but I've been exploring it in the background because I've been thinking about it, but not actually trying it out. But the challenge there is that Chris needs to, is writing data to an in-memory buffer, and then writing that in-memory buffer then to S3. So after you write the file and you close the file, we currently don't have a way of returning the statistics of the file without actually reading the file again. Now, to read the file again, if it's if it was a file on disk, it would be fine. You'd sort of instantiate the file writer and then just read the metadata and then get the statistics. But with an in-memory file that has just been written to, or a bunch of data, we actually don't have any functionality to read data from an in-memory source. So that's a bit of a constraint that I've been looking at. But with that said, I'm actually trying to see if I can modify the signature of the final function that closes the file. I added some text on the chat on the Slack channel just before the talk, so that's option 2 there on there. Also, option 1, I'm looking at the writer.close function returns an empty result, but I'm looking at whether we could return like the file metadata. And I can potentially share my screen. Let me see if I can do that. Now I have to play the game of how do you share screens. Oh, there you go. Fun.
Maybe while you start sharing your screen, Christian, could you maybe share a little bit more why the stats are useful to you, or why this is something, like, what's the use case here?
Yeah, it's mostly for optimization of reads when running queries from Databricks. So Spark SQL queries or Spark queries that you run from a Databricks notebook against a table that we would write from Delta RS can leverage the statistics to optimize the query and give better read performance.
Yeah, to add on to what Chris is saying, so you would have a file that has, like a bunch of chunks, chunk 1, chunk 2, chunk 3, etc. And then if you've got the statistics for each column, what you'll do, and we also do this in Data Fusion, if, let's say, for example, you're only interested in data where somebody's age is between 18 and 20, and here we know that the maximum is 15, let's say it's 1 year to 15 years, and then the other, you'd effectively skip this instead of touching it at all. So if we have so this is at a parquet. Can you? I assume you can see my screen. Sorry, this is at a parquet file level. So the file would have different chunks, but then beyond that, what Delta would then do is that for the whole file, it'll sort of say, well, okay, if this is one of, let's say, 100 files, we'll then say here we've got 2 to 50, and then let's do this quickly, and then 56 to 90. Very old people here. What you'd have with these statistics is that you'd have the minimum of 1 year and then the maximum of 90. So in the next file, if you're looking for somebody who's, let's say, 92 years old, then in this case, you won't even touch this file at all. So we need those statistics. Otherwise, if you don't have them here, you're forced to read the whatever reader will be reading will be forced to go here and then find what it needs. So it's
great explanation. Yeah, basically use the transaction log to pick which files you actually need to scan on the reader side.
Yes,
understood.
Better summary. So this guy here in this trait, the file writer trait, before this change that I'm exploring, I'm just letting the compiler guide me to see what else I need to change. If I get stuck, I get stuck. Sort of if I perish, I perish. So this guy here, when you close the file, it returned an empty result. So I'm just exploring what happens if we return, the actual metadata, the file metadata, because with the file metadata, you'll then have, there we go. With the file metadata, you'll then be able to, is it this one? Yes, it's this one. Sorry, I keep creating like random repos just to try stuff out. With the file metadata, what you'll then be able to do here, so here's an example where I was talking about the random data generator thing. I generate a large enough record batch. I think here we've got like 20 million records. I write it to the parquet file, and then to get the statistics, I need to, after closing it, I need to read back the file. But Christian wouldn't be able to do this currently. So what I'm doing now is just exploring if I could return the metadata here and then avoid the need to read the file. And then with the metadata, we can then get the column statistics. So these are the column statistics here, and this is the one that I was talking about. So if you've got
Hey, could you stop scrolling?
Sorry, this one. If you've got a byte array, Parquet will give you what the minimum of that byte array is. But with Arrow, we'd need to implement a kernel that calculates what the minimum of a byte array is.
So when you calculate that stats for byte array in the Parquet crate, are you not using Arrow to do that calculation?
No, we're not using Arrow. Sorry, it's actually a bit inefficient because we sort of doing it on a row by row basis. Okay, no, I won't look for the code. We're sort of doing it on a row by row basis. It's one of the things that I want to look at improving, because what happens is when you write the file, you can provide the stats if you've pre-computed them, or if you can provide, like, it's an option. If you provide nothing, it'll then compute the stats for you on a row by row basis. So where we could use Arrow is actually to compute the stats for the chunks or the batch or whatever, and then pass them to the writer so that it doesn't compute the stats. But now the problem with that is that sometimes there's a bit of a disconnect between the Parquet record batch, the Arrow record batch size and the Parquet row groups. So you would have in this instance here, we've got a record batch of, I think it's, what is it now? 10 million. Oh, it's 10 million records that I'm writing here, but because the Rust implementation actually doesn't split the batch into smaller chunks, it's writing the whole thing in one go. Sorry, I'll stop scrolling in a bit once I reach where I'm going. Here we are. So I've written a 481 megabyte file, which is one row group. So that's a problem from a parallelism for a reader perspective. So if Spark were to read this file that has been written by Rust, it wouldn't be able to parallelize it because now you've got only one gigantic row group. So this is related to the other item that I was talking about around creating a way of slicing a record batch, so that if you've got a massive record batch like this, where you've got 10 million rows, you sort of break it down maybe into chunks of 60,000 records so that you'd be able to write it down in small pieces. But now, going back to the discussion at hand of whether you could compute the statistics from Arrow, the problem there is if you compute the statistics at the parquet write level, if you compute the statistics for the whole record batch, and the record batch has 10 million records, what happens if parquet writes a chunk of, let's say, 100,000 records? You still have to compute the stats for just that 100,000. So I'm still exploring that. But it just specifically answers your question, QP. It's not a concern for me and Chris for now.
Yep. So it sounds like the parquet writer has its own row group split, right? Regardless of the size of record batch.
Yes.
Okay. So I guess the stats that's passed in from outside of the writer, it's not really useful in that case.
Yes. Unless you can...
From a performance standpoint, I don't understand why one would pre-compute the stats at the Arrow level, because it's not like you would pre-compute on one node and write on another. Like it's just you'd basically be just deciding where you want the CPU overhead to be in a single process either way, wouldn't you?
Yes and no. So if you're able to get the record batch sizes to equal to the chunk sizes, computing the stats in Arrow is more efficient, because if you're calculating the sum of a column, you're going to vectorize the computation. Whereas if you're doing it on a row by row base, it's that.
Okay.
So you probably save like a few milliseconds, well, depending on how big your data is.
So parquet writes stats calculation, it's all row by row. There's no vectorization at all.
The Rust library computes row by row. So it's part of the problem actually with the performance issue, the main performance issue with the Rust parquet writer and reader. So unlike the C++ implementation, for example, where they sort of rewrote the parquet write and read support, from the very low level, we took a more convenient route of saying, well, you've got the low level. Where's that thing? You've got the low level column writer. So this is where the stats are actually computed. So you see, you sort of say the minimum is the minimum of. Oh no, sorry, this is not it. It's oh yeah, here it is. So this is where you sort of computing your stats. We do it row by row, and the reason why we do this is that we use this function of writing the batch, the internal batch, instead of what the C++ implementation did, where they sort of reworked the whole support from scratch. That's why it took them like over a year or so to eventually get the write support completed. But what we did is, we sort of, using the low level column functionality, we materialized the error values into the primitive types, which is a bit inefficient because we're creating an allocation here. We compute the definition and repetitions. We're creating 2 more allocations, and then we compute the minimum, maximum if we need them. So in the long term, and this is work I'd like to probably do in the next year or so, but in the long term, what we need to do is we need to be able to go from an error column without computing the definition and repetition, and sort of, in the ideal state, we would iterate through the error column and compute these things as you go along. For primitive values, it's easier, but once you get to lists and structs where it's deeply nested, it becomes a bit tricky. But this is the sort of direction that we'd like to take. And when we take that direction, even the computing of stats will probably be a bit easier, because we'd sort of then be able to say, well, for this column chunk, for this column chunk that we want to write, we only want to write like 10,000 of the 100,000 records in this arrow column. So let's do a 0 copy slice of the arrow column, compute the stats for that quickly, and then pass them here as an option, instead of then having to calculate them sort of on a row by row here.
Yep, makes sense. I think as long as it's something that we can change in the future, then I'm not worried about it.
Yes.
So I'd like to encourage more discussion around this in the Slack channel. We're coming to the end of the time. I was really hoping that we would be able to give Florian an opportunity to share some of the partitioning and filtering work that he's been doing lately, and maybe share anything that he's learned from the the deployment of Delta Lake Python in production.
So yeah, we will talk about it in a next meeting, I think. But with pleasure to share insight on what are the use cases that we faced using data arrays in production.
I apologize, Florian. I tend to talk unabatedly.
Yeah, we can cover that in the next meeting if you'd like, Florian.
No worries, it was really interesting.
All right. Well, with that, we are a little bit over time. Florian, I'll put you right up front at the beginning of next meeting. And everybody have a good day. Thank you for joining.
Thank you, everyone.
Yep. Have a good day.
See you next time. Bye.
Thank you, everyone.
Bye.
Bye.